Managing the lifecycle of an AI model helps teams build solutions that stay reliable over time. In Azure Machine Learning, you can map each stage from data prep to monitoring, so the work stays connected to the business goal. Start with a clear business goal so every technical step supports the outcome. Translating a business goal into technical tasks involves close attention to data. The first main phase is data preparation. Azure ML organizes information in workspaces called data assets, which can be found under the Assets section in the Data tab on the left. To begin, data must be checked and potentially modified for accuracy, relevance, and consistency. This process, called preprocessing, fixes errors and missing values so training performs better. Structured and clean data is much easier for AI models to understand. Azure ML allows data to be transformed, split into training and test groups, and labeled when needed. Labeling makes sure each example has the right answer attached, an essential step for supervised learning. Properly organizing data saves time and helps avoid costly mistakes later in the project. Before you start training, make sure you're inside a specific Azure Machine Learning workspace. From the newly created Azure ML Resources Overview page, select Launch Studio to open your workspace. The Studio hubs appear on the left. Under the Assets section, you'll find data, jobs, components, pipelines, and more. Under the Authoring section, you'll find notebooks, automated ML, designer, and prompt flow. Under the Manage section, you'll find compute, monitoring your models, labeling your data, and connecting to outside sources. After preparing the data, the next phase is training the model. Use the Authoring section to configure training via AutoML. Submitting a training run creates a job that tracks your runs and outputs. In this demonstration, some recent automated ML jobs have been created, such as image classifier or sales forecast. AutoML allows you to submit a training run that creates jobs automatically, tracks runs and outputs. Training is where the AI system learns from historical examples, identifying patterns that will be used to make future predictions. The choice of algorithm, which is a method for learning from data, depends on the problem's nature, such as predicting numbers, classifying images, or analyzing text. To create a job, click New Automated ML Job. You can keep the default job name. Create a new experiment named Credit-Demo. Leave the description blank and select Next. Select the ML Flow Sample Data Train dataset. Then choose Classification as the task type and select Next. For the target column, select the Credit Risk Indicator. Review the training limits briefly. Then, for validation, choose Train-Validation Split and set the model limit to 5. Keep the default serverless compute. Click Next, and then Submit Training Job. AutoML will now run trials to identify the best models, which you can then register and deploy. Once training is complete, the next step is saving and tracking the model. This process is known as model registration. In Azure ML, model registration assigns a unique version number and keeps a record of when and how the model was created. This is important for traceability. Knowing exactly which version solved a particular business problem allows for reliable updates and troubleshooting. Managing versions helps teams compare different models over time. For example, if a new version performs better, it can safely replace the old one. Historical models remain available for audit or review. Proper model registration keeps work reproducible and makes compliance with industry regulations easier. The deployment stage puts the trained model into real-world use. Navigate to the Endpoints tab on the left side of the interface. Azure ML's Endpoints section is where models become services that can answer questions or make predictions in real time. In the Endpoints hub, there are 4 tabs: Real-Time Endpoints, Batch Endpoints, Azure OpenAI, and Serverless Endpoints. Real-time endpoints are used for low-latency, request-response predictions. Batch endpoints are used for offline predictions and large-scale scoring jobs. OpenAI endpoints connect to the Azure OpenAI models, And serverless endpoints connect to models that do not require Azure-hosted compute instances. Choose the endpoint type that matches your scenario. Then configure the compute environment and scaling settings before you deploy. Models can be deployed on different types of computer resources. For high-traffic needs, container systems like Kubernetes are common. Kubernetes is a tool that automatically balances work across many computers, ensuring that the AI service stays fast and reliable. For small projects, simple virtual machines may be enough. Matching the deployment type with business needs helps manage cost and performance. After deployment, a key priority is monitoring. To review metrics for a specific training run, open the Jobs Hub and select the completed job to review run metrics, logs, and charts. Then select a subjob. For AutoML jobs, select Models and Child Jobs. Select an outputted model from the list. Select the Metrics tab at the top of the interface. The page will display metrics, logs, and charts for the selected training run. Proactive monitoring ensures that the model continues to meet business demands after being released. If accuracy starts to decrease, a situation called model drift, teams can investigate the reasons. Common causes include changes in the data the model receives or external factors not covered during training. Early detection allows teams to retrain or adjust the model, keeping operations smooth and reliable. Mapping each step, from business requirements to data, training, registration, deployment, and ongoing monitoring, creates a strong workflow in Azure ML. Breaking the process down into clear stages helps teams spot gaps and reduces the chance of errors. Managing these steps responsibly supports both technical excellence and business value. With a good understanding of the lifecycle, you are ready to apply these ideas in real-world projects. Consistent, repeatable steps build a foundation for responsible AI and create models that continue to deliver value as requirements change over time.